Please welcome Sana Kashgouli for studying computer science. Sana.
Hi. How many of you have solved the jigsaw puzzle? How many of you do the outside edges first? Great. So the idea is to find pieces based on their shape, right? Some other times we search for pieces based on the same color. Now, this is like the concept of pattern matching in bioinformatics, where puzzle pieces are genetic sequences, and identifying the matching pieces is what pattern matching algorithms do. They search for specific genetic sequences within large genetic data sets, or what we call metagenomes. Now, this is one of the applications of KRAKEN. KRAKEN is a bioinformatics tool first invented at Johns Hopkins University that shares the same name with the mythical sea monster on the left side of the slide. KRAKEN has a k-mer-based classification approach. Now, k-mers are short genetic sequences of size k that KRAKEN builds an index for them and labels them based on their origin in the genetic data set. Now, in order to classify a new metagenomic sequence, KRAKEN breaks it into k-mers, looks up the labels, and based on the most repeated label, determines its origin in the reference genome database. The purpose of my thesis, KATKA, which is the Finnish word for shrimp on the right side of the slide, is to reduce KRAKEN's size in terms of storage by taking k value at query time instead of construction time. But what is the difference exactly? Let's say you're craving some pizza. Now, construction time is like ordering pizza in person. Let's say you have 3 specific toppings in your mind. Now, 3 here is the k value. The pizza guy will put on the toppings on your pizza as you go, but once you're done, you've changed your mind. You want, say, 5 completely different toppings. That means the pizza guy has to start from scratch and rebuild your pizza. Query time, on the other hand, is like ordering pizza online. If you change your mind about your toppings, you can simply modify your order, and once you're done, you can place it. KRAKEN needs to rebuild the index every time value of k changes, which can take up a lot of space of storage and be costly. KATKA, on the other hand, with the help of different data structures and compression methods, can handle queries with different k values without the need to rebuild the index every time, which saves us space and brings more flexibility. Now, by enhancing KRAKEN's size and accuracy, researchers can analyze large genetic data sets without the need to rebuild the database every time, which makes it easier for them and leads to faster diagnosis of infectious disease, such as COVID-19, and has a positive impact on public health, such as early detection and treatment of this kind of disease. Now you can tell why my thesis name is KATKA, because even in reality, it is way smaller than KRAKEN. Thank you very much.